So if you read any of that long thing about acceleration problems, the first thing I said was don't panic. And here's the reason why. Look at the paper. First instinct is to panic. Now, I'm telling you not to panic because everything in life, everything, I'm pointing right at you. You can see me. I'm looking at you. I don't have to go on screen to show you that I'm looking at you. But everything in life, every problem in life can be solved in some manner or another by breaking it apart into bits. Okay? Now, this first problem is exceptionally silly because it only gives you one piece of information explicitly. But you can get the rest, not the rest, but you can get a lot from just thinking through the problem. So why don't we do that right now together? A cat is dropped from rest 6 meters above the ground. How long is it in the air? Let's break it down. A cat is dropped from rest. This seems important. I don't know why yet, but it seems important. From rest seems important. 6 meters, obviously important. Above the ground seems important also. How long? Okay, so for our first problem, we have some stuff. Okay, let's figure out what it is. From rest. When I'm thinking about something at rest, this is what I think. Okay, now which one of these things can we infer from this information? This thing is at a position and it is not moving. Okay? Not accelerating, not doing anything. It's not moving. That implies that whenever you see from rest, something is going to be 0, okay? And it's most likely going to be one of your speeds. Okay, so from rest implies it's starting out stopped. Okay, so here we are, here's my object. This is a cat, right before I drop it. Ooh, 4-1, Yahtzee. Okay, now you take this object, it is from rest. You immediately, as you release it with your fingers, it's not moving. It's like, oh, I'm stuck in midair for just the momentous of moments, and then it begins to fall and accelerates to the ground, right? So it looks like one of these two is going to be 0. And I think that it makes the most sense. It looks like I have to put my hand here for shadow. Holy crap. Anyway, looks like it's going to be the starting. From rest, initial speed therefore must be 0. You're dropping it at 0. Okay, now, final speed. It says nothing about speed in here. I don't see any meters per second anywhere in this problem, so we do not know that information. If you read on to the next part, you can infer that also. Next, final position. From rest, 6 meters above the ground. Well, let's hope that when you drop an object, it doesn't keep going through the ground. So its final position is the ground, 0. Its initial position, it looks like that information, it should be in meters. 6 meters, looks like that information is given to you as well. So 6 meters above the ground is where it starts. Now, it doesn't tell you the acceleration. Now, I may not have written this anywhere, and now I feel like the biggest jerk on the planet. Because the acceleration due to gravity is a very specific number that you will see over and over again in this class, and that is negative 9.81 meters per second squared. If I forgot that anywhere, which I probably did, now that I'm thinking about it, I ask for your forgiveness. I'm not giving you any extra homework for Friday because that would be evil, especially when you're missing some vital information. Now, how long? It looks like we don't know how long it took to hit the ground either. So here's our information, okay? We don't have this number and we don't have this number, but we have everything else, which is kind of nice. Now, we are looking for how long? We're looking for time. So when you're going through these problems, you need to look for an equation that has what you're looking for, okay? We're looking for how long, we need time. Does this equation have time? Absolutely, there it is. Does this equation have time? It has it in 2 spots, that's nice. And then does this one? No. So it looks like on this first part, we will not be using this equation. Now, let's see which one we can do now based on the stuff that we have. We need something that has x's in it, and we need something that doesn't have VF because we're looking for how long. We don't care about VF. All right, so this first equation, it has VF and it has no x's. So it looks like, or positions, it looks like we're not going to use that one either. Does this have everything we need? Does it have XF? Okay. X initial, 6 meters, good. V initial is 0, so this whole term will go away in a moment. 1/2 times A, and we have A. And we're looking for time. So we have everything but time. Now, we go into the mathematics portion. XF, 0. equals x initial, 6 meters, plus 0, speed initial speed, 0 times time. Anything times 0 is 0. We will get to that in a moment. Actually, I'll do it right now. That whole term goes away and turns to 0. I always draw it like that in class. The whole term goes away. Plus 1/2 times negative 9.81, which is our our acceleration due to gravity, times time squared. Okay, so we got this stuff here. Let's rewrite it without this middle term. 0 equals 6 meters minus, if you don't mind, 4.905 times t squared. Okay, so meters per second squared. It looks like we can solve for what we need. We need time. So we just algebra ourselves out of a paper bag, add 4.905 times t squared over to the other side. 905, whoa, t squared, meters per second squared. All right, equals 6 meters. Divide both sides by 4.905 meters per second squared. Okay. There we are. There it is. Okay, so now we're left with an equation. All this stuff on my calculator. Okay, so 6 divided by 4.905 equals 1.22. Sounds fine. Okay, so t squared equals 1.22 seconds squared. If you work through the units over here, you'll see that it's seconds squared. Take the square root of both sides. T equals about 1.11. Okay, 1.11 seconds. Now let's verify that with the rounded version, that's about what we get. I'll write 1.10 or just 1.1 so that it agrees more with the numbers we used. Okay, there we go. Cool. So there's the answer to the first part of the first problem there. Once again, steps. Steps. We find the pieces. There's one, there's one, there's one, there's one. We plug in the crap, find out what we have. Okay, next we look at our equations. We see which one is appropriate. In this particular case, the middle one was the most appropriate because it had the stuff we needed and it didn't have the stuff that we didn't need. That's a really bad sentence. Let me try again. Had the stuff we needed and it didn't have unimportant data like VF because we didn't have that, we didn't need it. Okay, very good. All right, now, next, let's look at the second one. Okay. Bring this back into view. What is maybe take it out of view. What is the final velocity of the cat when it hits the ground? Okay, so we got final velocity. What is that? So it looks like we are now looking for this quantity. However, we now have a little bit more information. We have the time it takes to hit the ground, 1.1 seconds. Okay, so now we have everything, and all we need to do is solve for VF. Okay, so now we look in this equation thing, which ones involve VF? Well, the middle one doesn't involve VF, so we're definitely, get out of here. We're definitely not going to be using that one. The top or bottom one now will work. Now, if you are a regular human being that is not looking for a fight, you are probably going to go for the one that looks like this, as opposed to the one that looks like this. Okay, whenever people see a squared, they freak out. Turns out the math isn't too terribly different between these two in this particular problem. But let's go for the top one because most people would probably go for that. Okay, VF equals, we don't know, equals, now V initial, we already have it, 0, plus A, which is gravity's acceleration, 9.81 meters per second squared, times time, okay, and that time is 1.1 seconds. So now 9.81, I guess I'll do the negative for you, times 1.1 equals, looks like our final speed when it hits the ground will be negative 10.7, and let's go to 10.8, round it down, or round it up, I suppose. Okay, so there's our final speed as it hits the ground. Now, you might be saying, why is it negative? Think about it very carefully. You got an object, it's falling. What direction is it going when it hits the ground? Well, I certainly hope that it's going down, because if it's going up, something's wrong. So that means that this negative sign makes sense right there. Okay, it's going down. The velocity is down. Okay, so there's number one. Now, you might say that this video is about 10 minutes long. The actual process takes a lot less time when you are not describing every single step, okay? So this problem probably is a lot less long than 10 minutes. Okay, this is just me saying every single step to every single part. Okay, so next video is going to be another one of the problems from that homework set.